Well, I want to do an example on Friday that I want to put together a new example. Maybe I will do a play with a bunch of actors. That'd just be confusing though, overloading the word actor. All right, let's get started. Oh, I actually do want to. Oh, I don't have that here. If you got an error on the millis, that means you didn't import the. Geez, I forgot what it's called. The that import from the system. Can't hear me. No, it's fine. Looks like we have audio. Unless you type that. I did have the mic muted at first. So maybe you typed that before. There's a big delay on Twitch if you're on mobile. So they might be on mobile. And I had the mic muted for a few seconds when I started. But quick announcement before we... Yeah, if you mean millis, you have to do that import system dot... I forget what it is, but we'll talk about it in today's lecture. Dot underscore at the end of it. If you don't have that import, you'll get an error on the millis. You have to have that import inside your main method or your app if you're using the extends app. Lana has a question. I can hear you. So one quick announcement. Most of you, hopefully all, but I'm not that naive, saw this on Piazza already. But I did post the expansion objective logistics and the open-ended. I gotta think about that. The open-ended objective logistics. The application, the expansion objectives, the ones for each homework. I've said this a few times, just here and there. I don't think I said it during a lecture yet, though. So let me make sure I do that. Do that now, and talk about the logistics of this. And it's in the Piazza post too. But I just want to make sure it's out there a few different times. The expansion objectives are not due at the same time as the homework assignment itself. The expansion objectives are due April 10th. They were going to be due April 8th, but all the Friday deadlines got moved to Sunday. So April 10th, 11:59 p.m. And you can go back and do any of the expansion objectives. Even if you didn't do that homework assignment, maybe you did the rhyming dictionary assignment, but you want to go back and do the physics engine expansion objective, you can do that. And whenever you do an expansion objective, submit to the original... Do I mean May 10th? Yeah, I do mean May 10th. Did I say April? April 10th wouldn't be a lot of time, would it? 2 days after the last day of classes. That should be May. May, sorry about that. Sorry for the panic there. April, no. Check the Piazza post, because I'm confusing myself now. May 10th. It's due in a month, about a little more than a month. So submit to the original homework assignment. So if you're doing the physics engine expansion objectives, submit to the physics engine application objective on Autolab under the under the learning objective, program execution learning objective, that thing, learning objective 1. Submit to that original one, and then submit that form. That form is your way of saying, hey, I did this, go check out my work. And then at some point in the future, no guarantee on the speed of this, but at some point in the future, I'll go and check those. If it's good, you'll see the application objective point show up in Autolab. If it's not good, I'll put the 0 as that application objective with some feedback as to why that's a 0 and what you can do to, what you missed, what you can do to fix that. If I think it's an innocent mistake, I'll say, hey, can you fix this one part, and then get the credit. The open-ended objectives is a little bit different logistics. Actually, let me open Piazza over here to make sure I get the right dates here. Yeah, May 10th. That's a big difference. The open-ended objective, if you're doing a second expansion objective for the open-ended objective, just follow the expansion objective logistics. Do 2 of those by May. I almost did say April. Good thing I did check. May 10th. By May 10th, just do 2 of those expansion objectives. You'll get credit for the open-ended objective without having to do any extra logistics. If you are doing an open-ended project of your own design, you do have to submit a proposal for that by, and since I already got one date wrong, April 19th, in a couple of weeks. By April 19th, you have to submit your proposal. If you don't submit any proposal before then you, if you want credit for the open-ended objective, you have to do a second expansion objective. That gives us time, me and the TAs, time to review all the proposals and tell you whether they're approved or not. We'll contact you. We'll say whether your idea was approved or not. Once your idea is approved, you can go ahead and finish it, and you have till May 10th to finish your open-ended objective once we agree on the terms, so you know that it's going to be approved. I want to avoid someone doing a project thinking it's going to count for the open-ended objective, submitting it at the end of the semester, and then having me say, whoa, that doesn't count, that doesn't meet the criteria. So we're going to avoid that by having an approval process. And you can always change your mind too. I shouldn't advertise that, I guess. But if you have a proposal approved, you can still go and do a second expansion objective. If you're doing, if you're doing two expansion objectives, you don't have to do any of the open-ended logistics. You don't have to submit a proposal that says I'm going to do a second expansion. There's no extra logistics for that. You just do two expansions and fill out the expansion form twice. 3 days, get moving. And yeah, thank you, Protege. Protege's been asking for this, so anybody else who wanted it, thank him or her. Protege, I got your calculator expansion. So I did add an expansion objective to the calculator assignment. So go to the calculator doc, and at the bottom there's a brand new expansion objective. And there will be, once clickers release, that will have an expansion objective. And there's potentially one more expansion objective on calculator, or not calculator, on clicker's companion assignment, which is still to be determined, to be finalized rather. If you did the rhyming engine and want to do the physics engine, do you? I mean, maybe. So if you go back to an assignment you didn't do, but you want the expansion objective, do you also have to do the primary objective? Do you have to get a 1 on the primary objective? I'll say not necessarily. I'm not going to give you code for the primary objective. I mean, that's silly. But you will have to do whatever parts of the assignment that you will need to complete the expansion objective. But I won't be saying if you don't have a 1 for the primary in AutoLab, you can't get the expansion objective. I won't say that. If you're able to get the expansion without the 1 for the primary, which I think in most cases would be tough to do. Like if you can do the expansion, you can knock out the primary in no time. But 2 expansions doesn't equal 1 open-ended. But I mean, read the syllabus. You can answer that. We don't need, or ask during Q&A. I gotta get lecture started. Either, yeah, exactly. Right below BR Stosey. 1 expansion, 1 open-ended, or 2 expansions. Those are your options. So we can do second expansions, place of the open. Exactly, yeah. All right, so let's get lecture started. I think that's the big logistical thing I want to talk about. Let's get lecture started. So we talked about actors last time and how we have multiple pieces of code running at the same time. And we have this idea of time introduced into our apps. So we no longer have just a sequence of code running as fast as it can, and then we just check, did it do the right thing? When we want to test these things, when multiple pieces of code are running at the same time, we do have to think about time itself in our tests. So testing gets a little trickier when we have multiple things happening and passing messages between themselves. So we're going to talk about how to write unit tests that are going to be able to test these actor systems. To this end, we want to create an actor which is going to represent a bank account, which is going to accept deposits and withdrawals and be able to be asked for its balance. Very similar to the lecture question on Monday, at least in complexity. Instead of strings, we're working with ints. But it's very similar to the value actor in the repo. If you want to look at that as an example of how to have an actor that's just tracking a single value. Nothing too complex with the actor itself. That's Monday's content is just getting an actor up and running and doing its thing. What we want to focus on this time is the testing. This last bullet point, write a test bank account class is a test suite. It's going to test that functionality, and we want to talk about how to be able to do that. So let's talk about how to do that. So first, a little bit of background. Two things that we haven't talked about, a kind of type of class that we haven't talked about, and how to handle those traits. I very briefly mentioned traits. It came up in one lecture. I think I was showing code that used a trait. I forget what it was, but I very briefly mentioned traits. But we're going to start using these traits and mixins. So I want to talk about these just briefly. A trait is just like an abstract class, except it can't have a constructor. So the question here is, how do we extend multiple classes? And we're going to do that with traits. So a trait is going to let us extend multiple classes. So what if we wanted this situation where we have some object, it extends some other object for functionality, but we also want it to apply to our physics engine? How do we have it apply to our physical object, but also have some other class that it extends that don't necessarily have that aren't necessarily parts of the same inheritance tree? So maybe the other object doesn't extend physical object, but we still want to use that, both pieces of code. So traits, I blanked on it last time I mentioned traits. I knew there was one thing that I was missing, but I didn't want to misspeak. Here I'm giving you the definitive answer. It cannot have a constructor, but these can declare state variables. They can declare behavior. They can have all kinds of functionality, just like an abstract class can. And these are can be abstract. They don't have to be fully defined, but they cannot have a constructor. Due to this restriction of not having a constructor, we're actually going to be able to extend multiple traits by the same class. So a trait is going to answer our multiple inheritance question. If we want to inherit or extend or inherit from multiple other classes, we're going to define all but one of those or all of them as traits, and then mix those traits in, is where the terminology mixin comes in, to be able to get all that functionality. Now, when we want an actor, say we want to, oh, this is code you haven't seen before, but that's fine. So I want some class that extends multiple other classes, in this case, a class and a trait. We want something to be an actor. So it works with our actor system, which isn't going to extend like our physics object or any of that stuff. And we're going to extend actor to work with an actor system, but also mix in a trait. And we use the keyword with for this. So this class is going to extend actor with the mixin database, where database is a trait, meaning it has no constructor. And that's going to get us this multiple inheritance that we're looking for right now. So we can have multiple types of behavior, extend multiple types, and be parts of multiple inheritance trees, or multiple inheritance subtrees rather, with this mixin idea. So now we have everything defined in database and everything defined in actor. We're going to have, this is actually part of the clicker code, so some of this you'll probably see in that assignment, depending on how much I redesign. And these parts that are part of the database mixin will implement those abstract methods and also override that receive method in the actor class, that abstract method. So we're overriding everything. We have the contract for both of these. Actor needs a receive. Database, in this case, needs these 4 methods implemented. They're all abstract in the database mixin, the database trait. So now we can get this behavior that we want, basically multiple inheritance. Okay, so with that setup, I promise that'll come back. That wasn't just for that database example. But how do we test these actors? So there's a problem here when we have concurrency in that the code that we run to set up the concurrency is going to continue executing after our actors are set up. So once we set up our program, let's assume that we're going to use what we've used all semester, this function suite. We're going to run our test suite. It's going to start up the actor system. It's going to create some actors, call props and actor of, and set up the system with all these actors that are running concurrently. We can fire off some messages to get these actors, get this system started, get the ball rolling, and have them start communicating back and forth. And then after we send those messages, we're going to run some assert statements. Those assert statements are likely to execute before the first message is even processed, though. This is our issue, is we're telling all these actors to run concurrently alongside our main method. So when we get to our asserts, there's no guarantee that those actors have done the things that we want them to do before that assert is hit, or any asserts that we're testing. This is our problem. We can do this very horrible thing that I actually showed it during Q&A. Thread.sleep, showed twice, once to myself, but we can do thread.sleep, which is going to have just that one thread wait around, and then we can check the messages, check the actors, and see if they did what they need to do. But we also have another problem. Our function suite, our test suite, can't receive messages from the actors. If the actors send that back messages, we have no way of receiving and reading those messages. So we don't have a convenient way to really interact with these actors at a meaningful level with these restrictions. We don't know where they are in time. We can wait, but we can't get information back from them. We can get them started, but how do we get information back? As humans, we can print to the screen and look at the screen, but our test suite can't access that information, at least not in an easy way, not in a convenient way. So these are the problems that we need to solve, and we're going to pull in a library. This is what a lot of coding is, to be honest, these days. We're going to pull in a library, and that library is going to help us out here, so we don't have to build everything from scratch. So let's pull in another library. The ACA library actually has a testing framework with it, but it doesn't import with the ACA library itself. So when we import ACA to get the whole actor system and everything to do with actors, that doesn't come with the testing library. That's a separate library that we have to add to our POM and add this, what they call a test kit. Add this test kit to our POM and then download this library as well. So if you don't have that in your POM, if you haven't been using the POM from the examples repo, go to the examples repo, grab that, or type this up, or better yet, go to Maven Central and locate the dependency yourself, which is good practice for finding other libraries. So we're going to use this test kit library. And our test suites are going to look something like this now. So instead of extending fun suite and writing our test suite like we've seen all semester, we're going to extend this test kit, create an actor system, and then our mixins are going to come in here. We're going to mix in a lot of classes, or a lot of traits that are going to give us functionality in different ways of setting up syntax in our test suites. So let's look through this and see what this is doing. This is our first example of a test suite that's going to test an actor system. And the link on the the version isn't too critical here, as long as it starts with a 2, as long as it's not a major change, a major revision. This does have to be 2.12, Scala 2.12 though. So let's step through this thing and take. Oh, I didn't fix this green box. I fixed most of them. Let's take a look at this and talk about what each one of these is doing. Ooh. So first we have to import everything we're going to use from this library and some from Scala test itself. This is working with Scala test. So let's pull in our imports, and one of the important ones here, one that's easy to that's not the right way to say it. Easy to forget, hard to debug maybe. And this was one of the questions earlier. You have to have some of these imports that just import everything from a package. And in this Scala concurrent duration, this is where your millis syntax, this 100.millis, that's what's going to allow us to use that syntax. Without importing this, you'll get an error here, and the error is not going to say, hey, you should probably import Scala concurrent duration. It's not going to tell you to import that, which makes it a little tough to debug. You just have to remember that, hey, I need this line right here. The most annoying part is when you delete every instance where you use .millis, IntelliJ might clean up your imports and delete this line, and then when you add your millis back in, you're going to get that error. So it is an error, it's something to look out for. It's an error that does creep up quite a bit. The answer that I gave at the top of the lecture with the .millis, I was thinking of something else that we'll also see when we want to send multiple messages at a fixed interval. Actually, I was supposed to go to Monday's slides and finish that one up, wasn't I? We can go back there during Q&A maybe. Anyway, if I just get through this, maybe we can go during lecture. Anyway, we have to import this duration to be able to use this millis syntax, which we'll see a little later. Then we want to extend test kit, not the test kit, not fun suite. And this test kit constructor is going to take an actor system, and we're going to create a new actor system right inside of that constructor call. So we're giving this a new actor system. We're going to give it some name, just like we did when we set up our actor systems on Monday. We're going to set up that actor system and give it to this constructor, and then we'll have access to that actor system while we're doing our testing. We're going to be able to work with this system. We're going to see this system in our testing later on, so we can add actors to it and interact with it. And next, we're going to see all of our traits that we're mixing in. There's a lot of action going on with all of these, which is going to enable us to do this kind of awkward-looking syntax with these words like this. There's a good amount going on here. This before and after all is giving us this kind of functionality, which this is going to run. I don't have a slide on this, right? Yeah. Oh, I do. Yeah, I thought I did. I'll talk about that in the next slide then. But these are going to give us this functionality to write this, what we call behavioral testing. So this technically, I'll still probably refer to this as unit testing. But strictly speaking, we're not doing unit testing anymore. We're doing behavioral testing, where unit testing is testing one unit of functionality, usually one function, which is why we extend function suite. With behavioral testing, we're testing the behavior of a chunk of our program. We're taking an actor and saying, do you behave in the way that we expect? Or this whole system, does this actor system behave in the way we expect? And we're going to use this syntax and this stuff that kind of reads like an English sentence. A value actor must track a value in this test. That's what these imports get us mostly. I believe word spec like is what's giving us this specifically. This after all, this comes from the before and after all mixin. This is giving us a method named after all and before all, if you want to use that one. That's going to run after all that. I don't mean that to sound so redundant, but after all of the tests execute, we're going to run this code. So after all is going to help us gracefully shut down this actor system. Otherwise, an actor system is going to run forever. If you ran the examples from Monday's lecture, or you tested your lecture question code from Monday, just running the actor system, you'll notice that it never ends. That program never stops running. It just runs until you manually stop it. This is going to prevent that. It's going to let our test actually end instead of just running forever. After the asserts run, how does your actor system know to stop running? So even if you get to the end of this block of code, your actor system is still running on all these other threads. So your program doesn't shut down until you tell all those actors to stop. That's what we're going to do here. We're going to say shut everything down. We're done with all of the testing here. After the tests execute, shut the whole system down. So our test actually gives us that green bar. We get those green check marks, and instead of just running indefinitely. We also have before all. If there's any setup you want to do before a test, this is stuff we could do with FunSuite as well. If there's setup you want to do, because this is part of Scala test, not the new test kit. If there's some testing that you want to do, some setup you want to do before all of your tests run, you can initialize those. You can initialize those as well in a before all. And then finally, our testing itself. So this syntax that reads kind of like an English sentence, this is all set up with our behavioral testing mixins. So we can use this syntax, and then we'll set up run our tests in here. These are names of the tests. So just like our test suites, our test cases had names in the Fun suite, these are the names of our tests. So when a test fails, it's going to tell you which ones failed. You have multiple ins. You get this chunk here. You have multiple of those inside one of these. Sorry my lack of terminology there, technical terminology. But like this is the name of the test suite. Oh no, that would be this. Anyway, it'll tell you these names when something fails or passes. These will be the names that display in your console, or in the GUI in IntelliJ. Yeah. In word spec like is I don't know, kind of awkward, I guess, the way it actually does things. So these actually aren't strings, but I don't know. It's just write it like this. We don't have to talk about it right now. We don't have to get that deep into the language, but I wanted to mention it in this slide in case you're wondering what the hell this is. This is actually valid Scala syntax, but the word spec like creates a wrapper class around strings that uses the same syntax, and then must is a method inside this string wrapper class. In is a method inside that same class, and then that method is called on a code block. So let's actually test these things. We have our test suite set up, which is mostly boilerplate. I want to explain what this is, but most of this is just boilerplate. You're going to use all of this code, change your test names, and then write your testing here. What you'll be working with is inside that test. How are we going to test our functionality? So first, we're going to have access to that actor system that we gave to the constructor. That's going to be stored in a state variable named system. And then we can use that system just like we would the systems from Monday's lecture. So here I'm going to take the value actor class. It's an actor. I didn't talk about it, but it's in the repo. It just tracks a single int. Take an int. It can respond to the increase message to increase that int. And when it receives the get value method, or the get value message type is a case object in this case, it'll return an object of type value containing the current value that it's storing. And it's just tracking a single value, much like your lecture question on Monday, where you're storing a single value. You can append to that value and then ask for that value back. So I'm going to create an instance of one of those and add it an actor of that type, give it an initial value, pass that to its constructor, and store a reference to it. I want a reference to that actor so I can send it some messages. And add that thing to our system, to that test system. Next, do just like we saw on Monday, I'm going to send some messages to this value actor. I'm going to make sure I want to test that it did respond appropriately to these messages. So I'm sending it 2 messages of type increase with value 5. So it's going to receive one of them, increase its value that it's storing to 15, receive the other one, increase its value to 20. That's my expected behavior, and that's what I want to test. In here, and all that set up for this one, this is where the first kind of trick comes in, is if we test if we send this get value message, so we want to send it to increases and then a get value, and then see what it responds with when we send it the get value message. The problem is if we just send 2 increases and a get value, even though in our code we send increase, then we send get value, we actually have no guarantee that those messages will arrive in that order. So this get value message might arrive before the second increase of 5, and it might respond with a value object with the value 15. It's something that is very possible, even likely. If you run this enough times, you're likely to see that kind of behavior. You're going to, you can't guarantee that the messages will arrive in the order in which you sent them. And this is a big deal. This is a big thing we need to be concerned with. As always with concurrency, these things are happening at the same time. Sir, we're sending them in this order, but after we send them, we have no control over what happens. The whole design of this whole thing is to happen concurrently, so we have no control over what happens after that. So how we're going to get around this is just wait a certain amount of time, and we're going to wait enough time to make sure the messages resolve in the order in which we expect them to resolve. So I'm going to wait 1/10 of a second here, which is way more than enough time to make sure that these messages get there, that both of these messages are processed before we send this get value message, to make sure we get the right order. So we're going to force everything to happen in the right order to get the proper testing that we want. Is the sending random, or is there some method to how it gets executed? Like how the messages are sent. I mean, it's not random strictly speaking, but from our perspective, it might as well be random. The actor system is going to send those messages through whatever algorithms it has. It's going to send them through whatever threads are handling the message passing, and the order might get jumbled up in that process. We can run some code. We can actually do some tests after this and see, which I'm hesitant to do because we might just always get lucky and always get them in the same order, but we can try. But in our testing, we want to make sure we don't want to leave anything up to chance. We're going to wait. So this expect no message, this is going to say my actor system that I'm in, this test. So the testing actually sets up a test actor, which is the actor which we're in, if that makes sense. That is going to actually be able to receive messages. So we had the problem, if we have a main method and we're setting up an actor system, we can't receive messages like we mentioned earlier. We can't receive messages from the actors that we have. If an actor responds to sender, we just don't have a way of grabbing that message. But the testing library, through this expect no message and expect message type, which we'll see later, can receive messages. If an actor responds to the sender, we will get those messages in this test case. So this expect no message is saying no messages should be received for the next 100 milliseconds. So just wait for 100 milliseconds. Don't do anything, but importantly, don't freeze the whole thread like thread.sleep does. Just wait 100 milliseconds, and if any actor message is received during that time, so if value actor happens to respond to the increase message, respond to the sender, if any message is received during this time, fail the program. This test case fails at that point. We have to have no messages received for 100 milliseconds, and we use this not just to say we don't expect a message, but to say just sit here and wait for 100 milliseconds before I send this next message. And if we do happen to get a message in that time, then break, because that's just not what the system is supposed to do, not what this actor is supposed to do. Value is of type value. I'll talk about that. I do have some things to say about value. Value is a case class with one variable, which is an int. I do have something to say, and it's important that important for the lecture question. Not to keep you in suspense or anything, but so then we're going to send the get value, and we expect the value actor to respond with a message to send its sender a message containing its current value, which we expect to have the value 20. So at this point, we do expect a message. So we're going to use the other method. These are the two big testing methods that we'll see, which is why I want to highlight both of these and spend some time on this example, because this example encompasses pretty much all of what you'll need to know to test actors. So this time I do expect a message, so I'm going to use ExpectMessage type. There's a lot of different ExpectMessage methods in this library. The one I find with the simplest syntax, the one I recommend to you, you'll feel free to use the other ones if you want to read documentation, but ExpectMessage type, and give it the type of the message that you expect and the time frame in which you expect that message. There's a bit going on here, so let me break this down a bit. So I expect to receive a message of type value, and the time here is a maximum amount of time. If this, so this is going to wait for up to 1 second for a message of type value. If 1 second expires without receiving a message of type value, the test fails. There's an assert method. There's an assert statement inside this expect message, several of them actually, that's going to fail, and it's going to fail the test suite. So if no value is received in 1 second, done. This assert won't even be checked. Just done. Run the after all. Close down the system. It's over. If we receive a message that's not of type value within a second, it's also going to fail the test. We got the wrong message type. Not going to do it. We can't work with that. If we receive a message of type value before 1 second, we're going to return, get that case, that object of a type case, of a case class type, but we're going to get that message. I'll call it a message for consistency. We'll get that message. This will return that message, and then we'll move on to the next line of code immediately. So this 1,000 milliseconds or 1 second is a maximum wait time. If you have a statement like this in your test, that does not mean that your test will wait for a full second right there. So if I send this get value, most likely what's going to happen is value actor is going to get that value and respond with a message of type value within like a millisecond or so. So this expect message type is going to call. It's going to wait for up to a second, but in a handful of milliseconds, it's going to get, if everything's working right, it's going to get a message of type value, return, and move on to the next line immediately. So do not expect, when you have this expect message type in some time frame, do not expect this to actually take a second. In most cases, this will only take a few milliseconds. On the other hand, it's safe to increase these values to ridiculously, like you could have 10 seconds here, you could have an hour here. As long as things are, you wouldn't want to do that. But it wouldn't hurt anything, because if everything's working right and your tests are passing, you're not actually waiting that amount of time. And this will be important for the clicker assignment. If you say wait a second right here, you don't want to expect a full second of idle income during that time, because you're not waiting a second. You're waiting a few milliseconds just until that message comes and then moving on. But if you wait a full second without receiving that message, then fail. This is a max time. Whereas expect no message, you are waiting that amount of time. If this was 1 second, your code will wait for 1 second here, unless it does receive a message and fails the test suite. So those are the two big methods that we'll use for testing actors, and it's all about this, having this concept of time in your test. Our programs really care about time these days, so we are adding this this extra dimension to our programs, and it's a little mind-bending. It's going to take a bit to think about, but we have to be aware of the actual real-world timing of our actors, since things can happen at the same time when we want to control the order of things that happen, which primarily is during testing, at least for our purposes. We need to be aware of that timing. We need to be aware of time. And then finally, value. We want to check that we got the right value, so we do expect value of 20. There is an important note, and I should have, yeah, I got a few slides on this. It's the last thing I need to talk about. So value, I got you, Hannah Bells. We got to talk about this here. So value is of type. Let me quickly go to the code and. So value is a case class with one value, which is of type int. That's what we need to test. We need to test this, that we got a value of a message of type value with the correct value of I in it. But here's where things can get spotty. Here's where we can get messed up here. I should not, let me clarify that. I should not say this value message that I received from my actor. I should not say value.I equal 20. There's a specific reason for this. It's kind of just related to the course in the way we have things set up. But this is important nonetheless, and it does tell us something about case classes that we mentioned briefly on Monday. If we do value.I equal 20, and my lecture question, like today's lecture question, says have a case class named this, have a case class named balance is the big one that you'll be working with in your tests. Have a case class named balance that takes an int in its constructor. We've talked about this throughout the semester, and it's going to be ever important right here. When we have this case class named balance, when you write your case class named balance, you're going to name that variable inside that class, inside that constructor, something. And if you say balance dot something equals, you're almost certainly not going to have the same variable name that I chose in my grader, in my incorrect and correct solutions in AutoLab. So you can't use that variable name because it's not defined in the lecture question. So we're back to this question. This situation, which is a common thing to forget about that during this one. So I want to make sure I put a spotlight on it. You're probably not going to name that the same thing I do. So we have to test the value inside this object without accessing it directly. And this is where we're going to leverage a feature of case objects, is that the case objects, or objects of a type that are a case class, I should say, are compared by value. So normally if we did something like this, we're creating a brand new value object, an object of type value with a value of 20 as its variable, which we don't know the name of in this example. We don't know what that variable name is. But we're going to create a new object of type value with that variable set to 20. And if we say equal this value, in the if these were classes and not case classes, we would expect this to be compared by reference, and this would return false because these are two different references. These refer to two different objects on the heap. So we would expect that to return false. Since these are case classes, the equals method is overridden to compare the values of everything in the constructors, in the constructor of this class. So this equal is actually going to compare the values that are in that constructor. It's going to say, is 20 equal to value dot whatever you named that variable? And we can get this comparison without accessing that variable. So we're going to leverage this feature of case classes and get our heads around what case classes are a little bit more. We have no new keyword. The companion object supply method, I don't think we talked about that, but the companion object supply method is implemented, so we don't need that new method. It's going to just call the constructor, and the dot equals is overridden, so these will compare by value. So this is how you need to test those balance. When you have some balance message, a message of type balance, you store it in a variable. You need to test it like this. You can't do balance dot how much money is in this account equals $50 or whatever. You can't test it like that. You have to test it this way, or else we're back to the variable naming thing. Then we have to define more specs that are irrelevant to the functionality, which we shouldn't be doing. And that's and then Friday we'll see more complex examples of all of this good stuff. Where Monday and today, that is all the information that you need about actors from Monday and today. But when Friday we'll see more complex applications. You can technically compare two different types, but as long as they have the same constructor value, it would return. Oh, can you technically? I don't know off the top of my head about that, if you can compare two different types like this, but my inclination is to say no, that they would have to be the same type. But I don't know. I'm not 100% on that. I don't fully know. But that's my guess, is that you would not be able to compare two different types. And then back to the lecture question. Let me quickly go. Can I find this quick enough? Yeah, I can. Let me go back to the end of the last lecture. I forgot to go back over these slides, and we do have a few minutes here. I'm gonna squeeze in everything I can. We got this. I very quickly flashed this supervisor class just to quick get our minds in the right spot. We had this counter, which is going to listen for the start message and start counting down, and then receive an is done message and respond with either done or not done, whether it's done or not. And then and we set up an actor system with 3 of those, told them all to start, and then watch them count down. What I flashed very quickly, I just want to talk about how this works. And we played around with this example in the Q&A last time. If you want to see a modified version of this example that actually works a bit better, shows some cooler things, go check out that VOD. But we built this supervisor class, which is going to take in its constructor a list of actor references. So these references that we get for these actors, we can move these around our program just like any other reference to any other object. This is a reference, an object reference that refers to a value on the heap, which is a reference to an actor, which can be used to send that actor messages. It's a mouthful, ain't it? But we have a reference to an actor, a reference to an actor reference, I guess, and a list of those. So in its constructor, we're given this a list of actor references, and then when this supervisor is told to update, when it receives a message of type update, it's going to send the is done message to all of the actors in that list that was given to its constructor. So it can communicate to all of those actors. It's going to send the is done, and then it's either going to receive done or not done from each of those. If it receives not done, we're just going to print to the screen that's not done yet. If we receive done, and that actor ref has not already told us that it's done, we're going to add it to the completed list, kind of like exploring nodes in a graph. Similar to that, we're going to say, okay, this one's done. Let's remember that it's done, and then increment. Completed that. Then if all of them are done, if we've counted enough so that every one of them's done, we're going to say all these counters are done. So this the supervisor is just checking in with all of these counters and checking if they're done. And when they're all done, it's just going to print to the screen, say, okay, everybody's done. So this is, which doesn't have, it's not too interesting a functionality, but this is how we can have actors communicating with each other without having to be in the main method where the system was created itself. We don't have to be inside that method. We can set up these actors, tell them all to go do their thing, and then have those actors just do what they're supposed to do by communicating with each other without having the main method, without having that thread need to keep prodding the system and telling them to do stuff. They can just behave on their own by communicating with each other. In sender here, it's whoever sent that message. So the sender, that's an actor ref to the actor that, for the actor that sent that message. So sender is an actor ref, and we can use that sender. We've been using that sender to send messages, but we can also store that actor ref. It'll be the same reference that we have from the constructor. It'll match one of those. we can store those actor refs that the sender method returns. And finally, to set up the whole system, we're going to create our 3 counters like we did before, but also create a supervisor. Its constructor takes a list of actor references. Each one of these, 1, 2, 3, these are actor references to the appropriate counter. And we're going to give it that list of those 3 actor refs. So this is how we can have one actor know about other actors and then communicate with them through those references. We just create some actors, put them in the system, and then tell another actor about those actors that exist, and then they can have their communication. Then we're going to tell those 3 to start, and then we're going to use this scheduler, which has this kind of awkward import, statement. We're going to import from the system itself this dispatcher package, which don't ask me why they set it up like this. I'm sure there's some reason. But with this import, the important thing to know here is if this import isn't here, you'll get errors all through here. So we have to have this import statement. So this scheduler, so we have this scheduler functionality. And then what this does, we tell the system to send the update message to the supervisor right now. So don't have any delay. Send this message right now, and also send that message every half a second. So if we want to keep sending messages to keep pushing the system forward, we can set it up like this to be able to keep sending a message at fixed intervals, keep getting those messages sent.